Welcome to the deep dive. So today we're jumping right into something pretty significant. A new US-made drone battery.
That's right. It looks like it could really shake things up for defense and aerospace.
Yeah, we've got some recent announcements, reports on Lyten's work out of California. They've had some pretty impressive flight tests too.
hmm
So the real questions are, what makes this tech tick and why is everyone calling it strategically important for the US?
Well, we're diving into this lithium-sulfur battery technology. Lyten, they're based in San Jose, California, and they seem really focused on changing how we power things like drones and satellites.
Okay.
And they're not just talking about it. They're actually setting up dedicated production right there in California.
Dedicated production. Wow. So for UAVs, satellites, defense stuff mainly.
Exactly. That seems to be the initial focus,
Mm-hmm.
critical systems.
All right, let's talk about that flight test. That sounds pretty interesting.
It really does. So they had a U.S.-made UAV
Mm-hmm.
powered solely by Lyten's lithium-sulfur battery, and it flew for over 3 hours straight. It speeds up to 86 miles per hour, too.
3 hours, and not just flying level.
No,
Yeah.
it handled complex flight patterns, apparently, without any issues. The drone itself was designed by Titan Dynamics, battery system from Upgrade Energy, both LA-based, interestingly.
Huh. Local collaboration.
Yeah, and get this, it was a 3D printed UAV, wingspan of about 8.5 feet, tested down in Palos Verdes.
3D printed. Okay, so 3 hours is already good, but they think they can do better.
That's what Lyten is saying. They expect to push that same drone to maybe 8 hours of flight time pretty soon.
8 hours. Right, so what's the magic here? What makes these lithium-sulfur batteries capable of that kind of endurance?
It really comes down to the basics.
Mhm.
Lithium-sulfur batteries are just fundamentally lighter than, say, the standard lithium-ion ones we're used to.
Lighter. Okay.
Much lighter for the same energy. So you get a higher energy density. That's the key term.
Right. Density.
And that higher energy
Yeah.
density, that translates directly into, well, longer flight times, like we saw.
Makes sense.
Or you could keep the flight time the same, but carry heavier stuff, more sophisticated sensors or equipment. It means drones can operate over much wider areas.
So more capability, more reach.
Exactly. And Lyten's chief commercial officer, Selena Mikolajczak, points out this isn't just for drones. Satellites, EVs, even things like e-bikes could benefit.
Satellites too. How does that work?
Well, for satellite applications, they're reporting over 3,000 charge cycles. That's huge for longevity in orbit, where you can't just swap the battery out.
3,000 cycles.
Well-
Wow. That's way beyond typical, isn't it?
It's a significant improvement, yeah. Really extends potential mission life.
Okay, so lighter, packs more power, lasts longer.
Yeah.
Sounds great. But you mentioned something else earlier about the materials. These batteries are made without certain things.
Ah, yes. This is really important. They don't contain nickel, manganese, cobalt, or graphite.
And why should you, the listener, care about that list?
Well, because those specific materials, nickel, cobalt, graphite, are heavily dominated by Chinese supply chains, like overwhelmingly so.
Ah, okay. The supply chain angle.
Precisely.
Yeah.
So by designing a battery that avoids those materials and manufacturing it entirely in the U.S., Lyten is hitting a really critical point about national security and supply chain resilience.
So they're meeting those NDAA requirements, the National Defense Authorization Act stuff.
Exactly. It directly addresses those concerns about the U.S. being dependent on foreign, potentially adversarial sources for critical battery components.
Right. And I think Lyten's CEO, Dan Cook, he framed it pretty starkly, didn't he? Something about relying on adversaries.
He did. He basically
Yeah.
said, look, our unmanned systems increasingly rely on batteries, and right now we're almost totally dependent on materials sourced from potential adversaries.
So Lyten's tech is positioned as the solution.
As a solution, yeah.
Yeah.
A high-performance, lightweight battery that's made right here, domestically sourced and manufactured. That's a powerful combination.
You can see why it's strategically important. Is there any government validation of this yet?
There is. They have a contract with the Defense Innovation Unit, the DIU.
Oh, okay. DRU.
And as part of that, Lyten is actually scheduled to demonstrate these batteries up on the International Space Station later this year.
The ISS. Seriously.
Yep. Talk about a tough testing environment. If it works reliably up there, that says a lot.
Yeah, no kidding. Okay, so let's try and wrap this up. For you listening, the key takeaways seem pretty clear. First, this is a potentially major step forward in U.S. battery tech.
Definitely. Could really boost what our drones and aerospace systems can do. Think longer flights, more gear.
And second, maybe even more importantly in some ways, it tackles that big reliance issue on foreign supply chains for battery materials.
Right. It strengthens U.S. energy independence and security, specifically in this really vital tech sector. It's a great example of the kind of innovation happening domestically.
It really highlights that push for technological self-reliance, especially for defense.
Couldn't agree more. It's about securing the power source.
So it leaves us with the final thought to chew on. As this lithium-sulfur tech matures, gets better and cheaper, how might that lighter weight and higher energy change things beyond just military drones and satellites? Think about commercial industries, electric vehicles, anything that needs better batteries and cares about where the materials come from. What ripples could this create?
That's a really interesting question for the future.
Definitely something to watch. Thanks for joining us for this deep dive.